Right. They already in class students are listening now. Right. Right. So what we're discussing about is that this year we have less rainfall, less snowfall in the Himalayas. Because of this, obviously, the river water will be lesser in volume. Due to this, we'll have agricultural crisis. At the same time, we'll also have impact on agriculture because of the groundwater recharge. We know that in the northwestern part of India, not only people are dependent upon canal irrigation, they are also dependent upon the groundwater recharge as such or groundwater extraction as such, especially in the fields of Punjab, Haryana, Uttar Pradesh, Bihar. So, if the water volume in river is less, that means groundwater recharge will also be poor. So, also anyway in this area, we are suffering from problem of over extraction of groundwater. So due to this, again, crop yield to a large extent will be impacted here, if not in short time, over a coming decade definitely. Plus soil moisture will be reduced as well, because from the river, whenever you have flood like conditions, the moisture is absorbed by soil. That plays a very important role in the cultivation of crops, especially water inefficient crops like rice, sugarcane and all that. So that is the point. Stress on rabi crops we have discussed, plus overall irrigation support will be less as compared to earlier. Forest fire we have discussed, dry forest floor condition. Uttarakhand itself has reported more than 1600 plus fire alert, again due to the dry condition prevailing. Himachal Pradesh similarly had received more than 600 fire alert. Same thing we see in the Jammu Kashmir also as compared to earlier decade. If you look at the long period average, last 50 years of data, these fire alerts are much more higher in number as compared to earlier years, and again directly linked with the global warming that has resulted in climate change, that also has led to disturbance in the overall winter rainfall or precipitation pattern. Plus there is a risk to glacier as well, because reduced snow accumulation will see in the glacier, and glaciers are melting at a rapid rate, and due to this glacial lakes can form, because rapid melting of glacier, if you look here, they will basically create huge volume of water flowing in the downstream region, and due to the erosion here and there we'll see accumulation of water, glacial lake. And if more number of glacial lakes are building up, we know that one of the major crisis that we face or natural hazard that we face is glacial lake outburst flow. So number of such disaster, risk of such disaster where glacial lake burst due to the amount of the water significantly becoming higher in this area, that risk will increase. And most importantly, we'll see upward shift of equilibrium line altitude. This is very important. Equilibrium line altitude refer to that height where the net mass of snow is zero. That means we can say the snow that accumulates is equal to snow that melts. So over a period of time, you will not see any change in the mass of snow. So that equilibrium line will keep on shifting further upward. If it is at suppose 3000 meters today, it will further shift to 3005 meter, further shift to 4000 meter. Why? Because of the impact of global warming. At such particular height where earlier sub-zero temperature used to prevail, now you will see temperature always remaining above 0 degrees Celsius, and that is why you will not see the permanent snow cover in this area. That is what we are talking about, the equilibrium line altitude, and obviously it would overall lead to reduced discharge as far as the flow of water is concerned. Now coming to second topic we have is related to Japan, where Japan has decided to pause restart of world's largest nuclear power plant. Earlier few days back they stated that we are going to restart our nuclear power plant, but again just after one day they have paused it. So it is a developing situation. Now if you look here, what is the reason behind discussion of this topic? So restart of nuclear power plant. It's a very big decision taken by Japan, because you know that in year 2011 Japan faced Fukushima disaster, which is considered as the worst radiological or nuclear disaster after the Chernobyl disaster you had in Ukraine as such. So Fukushima, somewhere here along the, you can see that along the eastern coast of Japan, you have the Fukushima nuclear plant. So on 11th March 2011, the plant suffered this nuclear, what you can call as this radiation leakage and damages in the reactors and all because of the tsunami triggered by the devastating earthquake. More than 9 magnitude earthquake on Richter scale was recorded here. So this earthquake and tsunami triggered one of the worst disaster. That is why Japan later took a decision of shutting almost all the nuclear power plants that it has in that particular coast specifically as such. Now the question is, from geography perspective, why Japan suffers or faces so many this disaster like earthquake, volcanism and tsunami. And reason we have discussed in class also that Japan, as you can see, is part of this longer or larger ring of fire as such. This is also called as circum-Pacific ring or Pacific ring of fire. Here we all have discussed about the nature of plate interaction. So here we have the oceanic plate, largest Pacific plate, and then it is subducting below the continental plate such as Eurasian plate. Here you have Australian plate, which is oceanic plate. So due to OC convergence going on around Japan and especially interaction between three plates, you have Philippine plate, you have the Eurasian plate and you have the Pacific plate. So these interaction increases the possibility of the number of earthquake and tsunami this region can receive as such. And because Japan is an island country and most of industries are located along the coast, along the port, and maximum damage due to tsunami we know occurs along the port area, coastal area itself, and that is why these nuclear plants of Japan are most vulnerable as far as the damage by these nuclear disaster is concerned. So we can say that to some extent they are suffering from high disaster exposure like condition. So Fukushima disaster, again to review briefly, magnitude 9 point earthquake to tsunami was triggered because of this. We already have discussed mechanism of tsunami in the class, and that resulted in the reactor meltdown because the tsunami waves, the water from the sea, were able to enter inside the nuclear power plant and they were able to enter inside the reactors itself. Due to this large extent, you can see hydrogen explosion was observed, and because we know that nuclear power plants run on the radioactive materials, you have uranium is there, so obviously radiation leakage was also experienced here. Now massive radiation was released during that time, and due to this the disaster was not only affecting the short term, in short term it has a long term consequence as well. Even today when scientists have investigated this area, they have found that due to massive radiation leakage, the soil and water nearby this power plant has become contaminated, and it has resulted in the evacuation of one of the largest evacuation operation carried out in the history of Japan, where more than 150,000 people had to be evacuated, not only because of tsunami related damage, tsunami related disaster, but also because of this radiation leakage as such. Plus marine ecosystem along this coast of Japan, again if you look, was also affected. So as you can see, Fukushima was here, and everywhere on the symbol that you are seeing is referring to one of the nuclear plant of Japan. As you can see, Japan has large number of nuclear power plant compared to the area that it has, a small island country it is. So to large extent its power facilities, we can say power production was dependent on nuclear energy. So most of these were shut down after the Fukushima disaster as such. So now again this decision was taken to start the largest nuclear power plant, restart largest nuclear power plant of Japan, and this one in recent time if you look, it is called as Kashiwazaki Kariwa. It is the nuclear power plant which Japan has restarted as such. So that has drawn massive criticism. People were also not happy with this decision of Japan as such. So overall, there is also economic and social impact of this, because any radiation damage, if it happens again, such kind of disaster happens again, and we cannot predict it, because again tsunami, earthquake, all of these are unpredictable in nature. So no one knows that when such kind of crisis will happen again. So over $200 billion of cost Japan will have to incur. Plus it has led to permanent displacement of communities. Plus we know that because of soil, water has become contaminated, not only industrial activity but even activities such as agriculture and fishing will be impacted, and that will lead to overall loss of public trust as far as nuclear energy is concerned as such. So that is the major challenge, and criticism obviously is same thing. People are scared because a lot of people have lost their family members. It is also associated with some kind of emotional trauma to many people who are living along the areas where you have nuclear power plant. So this psychological trauma has led to the residents in this particular area, in this particular reactor area, to protest against this. So large scale public opposition we are seeing. But as far as the government is concerned, it knows that Japan does not have huge amount of coal reserves, which is one of the major sources of power production in different part of the country, including different part of the world, including India. So in India, we know the majority of our power is produced from thermal power plant. So obviously government of Japan is trying to justify it by saying that we have to diversify our power production resources, and anyway we already have installed nuclear power plants in so many years as such. So restarting makes a logical sense, and also they want to show it as a kind of decarbonization effort. This step of restarting they are taking as a decarbonization effort because they not want to burn fossil fuel. Now what is way forward? Obviously if you are planning to open and restart nuclear power plant, especially if you are living in a vulnerable area, disaster resilient energy planning becomes very, very important, plus governance and concern. What kind of consent government has taken from the local public, and also the view of experts, their recommendation should be made transparent to the public as such. Diversified energy mix, obviously that is a good way of ensuring that your power basket is properly diversified, and it also is a key lesson for India's coastal nuclear plant which we are planning to develop in the future as well. So currently, as far India is concerned, about 8 gigawatt of power is generated by nuclear energy, and the government of India want to further increase it all the way up to 100 gigawatt in the future. So many nuclear power plant we are going to develop and set up along the coastal areas. So we have to be careful, and we have to learn our lesson from Japan that what we can do more to ensure safety of the people. Third topic is related to the delta submergence across the world. A recent report was published in a well-known journal called as Nature. So Nature has showed that if you look at the river deltas all across the world, we are seeing a systematic land subsidence. That means almost all the deltas around the world are showing some degree of subsidence. Subsidence means they are lowering in elevation. They are sinking basically, in simple term if it say. So all the river deltas are kind of sinking, and as far as the study over India is concerned, 6 deltas have been identified which are showing similar trend, which are sinking gradually below or inside the ground as such. And this subsidence which we are seeing in the delta, it exceeds the sea level rise as such. So the problem of flooding we will see in deltaic areas in the near future will not be because of rise in sea level, it is because of sinking of deltas itself. So gradual sinking of land surface, that is what we call as subsidence. It is naturally, we can say this is driven naturally because of the sediment compaction and tectonics. Many times isostatic adjustment is term that also use. Isostatic adjustment. Isostatic adjustment means we know that some places on the earth are higher elevation, some places on the earth are lower in elevation. So places which are in higher elevation, they apply pressure, and due to this places which are at lower elevation, they go up as such. This is isostatic adjustment. So as sediment load increases, the pressure over this area increases, and it try to basically apply downward pressure as such. Plus tectonic, we know that due to faulting or fracturing in the rock system. Due to faulting or fracturing in the rock system, also we can see subsidence taking place as such. Human factors to talk about, it has caused the increase in the, we can say the extent of subsidence as such. And the biggest factor responsible here is groundwater extraction. So if you try to understand, suppose this is the soil, this is the deltaic region as such. And below that, we have the water reservoir like this. And again, you have the impermeable rock layer or permeable rock layer, it does not matter. So you have delta, you have rock, and you have groundwater reservoir. Now we know that for our needs, whether for drinking water purposes, whether for the irrigation purposes, we are over extracting this groundwater. So if you extract groundwater more, the rock which was present here, it will start to subside, it will start to sink. Why? Because earlier water was applying upward pressure, or water was providing, we can say, as a support for it. But if you extract the water, this rock will start to go gradually down. And as this rock start to go gradually down, the deltaic sediment deposited above it will also start to sink gradually. So groundwater extraction plus urban load, again we are building a lot of construction infrastructures and all that, that also has led to sinking of the landmass overall. So this is naturally a geological process, but because of the human intervention, because of the increase in intensity, it has turned into what we can call as a crisis-like situation. So several satellite data basically was also measured from, basically we have taken here like Nature Journal, where the article was published, has taken data from the European Space Agency satellite called as Sentinel-1. INSAR technology, that is interferometric synthetic aperture radar, which measures how the ground elevation is changing, that also we have taken. And overall groundwater, sediment data, urban stress data. By looking at this scientific data, we can say that in case of India, Ganga Brahmaputra river delta, Brahmani, that you have in the state of Odisha, then you have Mahanadi again in Odisha, Godavari, flowing through the Andhra Pradesh, forming the largest delta there. Kaveri, then you have in Tamil Nadu, and Kabani. Kabani is a tributary of Kaveri. So where Kabani and Kaveri are meeting, there also you will see kind of deltaic formation as such. And Kolkata, where you have the Hooghly Delta. All these areas are basically, we are seeing this subsidence or submergence of delta as such. As far as the data is concerned, it is believed that more than 90% of areas affected in the major deltas of the world, whether it is Nile Delta, Amazon Delta, all the major river deltas that you talk about. And Brahmani River, if talk about in India, is the most affected one. 77% of the delta that is formed by Brahmani River in Odisha, they are subsiding at the rate of more than 5 millimeter per year. That means every year the river delta is going down, sinking by the rate of 5 millimeter as such. Mahanadi, over 69% of its area is sinking at the rate of more than 5 millimeter per year as such. So this is the key finding. What is going to be the environmental impact? Obviously, because deltas are the structures which are very, very near to sea level. Most of deltas, we can say in the world, are in the range of 2 meter to 5 meter above sea level. So if they keep on sinking without any, we can say with a greater rate, what will happen? A time will come when majority of these deltaic areas will go below the sea level. That will lead to coastal flooding as such. Compound coastal flooding, because one flooding is due to tidal effect. Second flooding happens due to the global warming that is causing rise in sea level. And third flooding at the same time. Sea level is rising, at the same time land is also subsiding. So due to the combined effect of all of these three, we'll see greater extent of flooding in the coastal areas that would obviously lead to permanent loss of land. Most of the deltaic areas in the coastal region will go below the sea level permanently. That means no one can reside and can use this area for agriculture purposes or for living purposes as such. Plus, as the sea water will be able to move further inward due to the subsidence of land mass, we'll see more part of the alluvial soil, deltaic alluvium more precisely, they will face the problem of salt water intrusion. That means salinity will increase, and we know that if salinity increases, the fertility will decline. So large part of the coastal alluvium which support agriculture would become wasteland as such. Plus at the same time, wetland and mangrove degradation we will be able to see there. Plus, we know that a lot of people across the world, millions and millions of people are dependent on the deltaic region, dependent upon the coastal fishing as such, agriculture economy as such. So to some extent, livelihood losses we will see here. Migration would be, obviously, climate refugee is the term that UN uses. People who have to migrate not because of economic and political factor, but because of the climate change related, or we can say due to the change in the climate as such, change in weather as such, change in the settlement pattern as such. So distress migration we will see. And the problem is that India also, if we have to manage it, we know that the biggest human intervention is the over extraction of groundwater. So in India, we have weak regulation as far as the groundwater extraction is concerned. This we have to obviously change. Plus coastal regulation zone that we have brought in, where we have clearly established that what kind of structures, infrastructure, what kind of construction, what kind of activity is allowed in the coastal areas. That also ignores subsidence as such. So subsidence is not being considered even as a problem. So unless and until you include this, then only you can do the planning to ensure that this does not affect the local life, local people, local economy adversely as such. Way forward is integrated delta management. We have to bring in regulation, rules, laws that is able to overall optimize the groundwater extraction as such. This is also needed in Punjab Haryana area where salinity has become a bigger problem. Urban zoning, mangrove restoration, satellite monitoring to understand where subsidence is higher, where subsidence is lower, where urgent measures are taken, right? All this have to be done, and this problem has to be integrated as far as the policy making of the government is concerned. So that is the third topic. Now coming to the fourth topic, that is the INS Sagar Dhwani. It was flagged off for 5th edition of Sagar Matri initiative. So INS Sagar Dhwani is a ship recently from the Kochi port. It was flagged off to participate in the 5th edition of Sagar Matri 5 mission. It is under the Southern Naval Command, and overall this initiative is taken by Indian Navy along with the Defense Research Development Organization, that is DRDO as such. So first of all, we have to understand what is Sagar Matri initiative. Now Sagar Matri initiative is a joint initiative taken by Indian Navy and DRDO, and here though INS Swagardhwani, it seems like it is a ship, okay, a ship largely for defense purposes used, but here this ship is being used for the scientific cooperation. The ship is being used for maritime scientific analysis, maritime increasing or enhancing our knowledge as far as the ocean floor, this sea bottom is concerned. And overall, it also aligns with the vision that Government of India has given. Earlier, it was called as Sagar. Later on, the Sagar was changed, and now Government of India calls it as a Mahasagar. So, what is Mahasagar? Simply, if you look here, Mahasagar refer to mutual and holistic, we can say M is mutual and holistic, and SAGAR, that is security and growth for all in region. So mutual and holistic alliance for security and growth for all in the region. That means this initiative is not only focused upon the growth of India or security of India. It takes into account all the countries which are along the rim of Indian Ocean, which are, we can say to some extent, are allied with India, are friendly countries with India. For them also, India has unveiled this policy. So overall, we can say it is nothing but extension of its naval diplomacy or maritime diplomacy as such. And overall, the focus is to ensure that regional maritime security is not compromised. The risk that we are facing collectively in the Indian Ocean should be handled and should be managed collectively as such. Mutual and holistic advancement, so security and growth across region. Maritime cooperation, capacity building, and focus is of over Indian Ocean region. You have many countries here. For example, India, then you have Maldives, then you talk about Seychelles is there, Kenya, then you have Mauritius, then you have Bangladesh, Sri Lanka. So these countries are involved as far as the Sagar and Mahasagar initiative is concerned. Now talking about the MATRI scientific component. So first of all, what is MATRI? MATRI again is abbreviated form of Marine and Allied Interdisciplinary Training and Research Initiative. So that is the overall clear from the term itself. Marine, that means referring to the oceanic areas, that is where we have to focus our research on. Allied means it is not a single country initiative, multiple countries which are part of Indian Ocean region are involved here. Interdisciplinary, that means we are not focusing upon any one discipline, we'll take help of multiple discipline, whether it is geology, whether it is chemistry, whether it is physics, everything will be included. Training and same time research initiative as such. So joint marine research program to some extent we can say, where different countries also have requested India to provide scientific training to their crew, and that also Government of India is doing. If you look at the countries such as Mauritius, talk about countries such as Seychelles as such. So overall the attempt is to build the capacity with the partner nations of the Indian Ocean. Objective of Sagar Maitri is simple. As we have discussed, it is a research based mission. So by sending ships, Government of India and other countries are trying to collect data as far as the ocean, deep ocean is concerned. This data is collected by using acoustic method. Acoustic method is, that means this is the ship, this is the ocean bottom. So ship is sailing above the surface. So they send sound waves. These sound waves then strike the surface and reflect back. And then reflection is a study to understand what is the depth, how topography is varying in the ocean as such, what kind of density of the different materials are present there, because different density material, basically we can say, will see the reflection of sound wave in different manner. So based on that, we can have a proper and complete understanding of the ocean bottom or deep ocean bottom. So that is the way how we are trying to collect data. Very important, because you know that these days too much emphasis is being given on deep ocean mineral exploration. So there are several minerals on the ocean basin below 200-300 meters, such as talk about polymetallic nodules, we have discussed about manganese nodules, we have talked also about what we can call as the polymetallic sulfides you will find, cobalt crust you will find on the geo we have discussed about, you have the sea mount and all that we have discussed about. So this you cannot explore and extract unless and until you do not have complete picture or comprehensive picture of the ocean bottom. So designated observation tracks have been established already. This is the tracks along which the ship will move and will keep on collecting data as such. The overall, we can say, the result will be underwater domain awareness. Domain awareness means simple, understanding of the underwater structures, geology and everything like that. This is the 5th edition, already 4 such editions we have seen where such kind of attempt has been taken. And in 1960s, we have a ship called as INS Kistana. So the route that was taken by INS Kisna for the research purposes will be exact route that this particular ship will also take. So retracing of INS Kisna route as such 1962 to 1965, that is when INS Kisna went over the International Indian Ocean Expedition as a part of International Indian Ocean Expedition as such. So again, to some extent, government through such initiative is trying to revive the collaborative research. This is very important, collaborative research, because in today's world we are seeing countries are becoming more parochial, more narrow-minded in nature. They are largely working for their own interest. But the marine exploration is such area where one country cannot utilize resources, cannot use resources to understand comprehensively. So collaborative research definitely will provide better effect, or better we can say result as such. INS Sagar Dhwani, if you look at the ship specifically as shown here, it is what we call as marine acoustic research vessel. Acoustic research, again emphasizing on the way of carrying out research, that is by sending sound wave, sending acoustic wave. Designed by NPOL in Kochi, built by GRSE, that is Garden Research Shipbuilders Enterprises in Kolkata. We know that in India we have Mumbai, Kochi, then we have Visakhapatnam and Kolkata, 4 major ports where shipbuilding is carried out. So GRSE, one of the major shipbuilders, Garden Research Shipbuilding Enterprises, commissioned in July 1994, primary oceanographic research platform this ship also hosts as far as India is concerned. So very, very important part of deep ocean mission that India also has announced few years back, and Samudrayan mission we also have announced with reference to that. The next topic is related to NDRF, that is National Disaster Response Force. Recently means on 19th of January, we have celebrated Raising Day as far as the National Disaster Response Force is concerned. So first of all, what is Raising Day? Raising Day is celebrated to celebrate the formation anniversary of any organization. So NDRF, very, very important organization. Prime Minister has greeted NDRF on the Raising Day on 19 January 2026. So it was on 19 January 2006, NDRF was raised, instituted under the Disaster Management Act of 2005. We know that till 2005 we did not have any special legislation to deal with disaster in India, to manage disaster in India, and then to back-to-back disaster we have to experience. One was Bhuj earthquake in 2001, Gujarat, we know, one of the most devastating earthquake that India has seen in the recent history. We talk about last 100 years, we have the maximum number of deaths we have seen is in the Bhuj earthquake 2001. And then in 2004, we know for the first time we experienced tsunami in the recent history, Indian Ocean tsunami, where the tsunami basically originated near the Java Island, Sumatra Island we have discussed. So because of these two back-to-back disasters, 2001, 2004, finally government understood that we need to have a proper legislation that will fix responsibility, accountability, and provide guidance that how any disaster has to be managed in integrated manner, both by putting state government, central government, so that the resources of both government can be pooled, proper chain of command can be established, who is responsible for what work, and for that the act was given. So a specialized disaster response force, one of the provision of this act is to create a specialized disaster response force. Now before this act, disaster management was largely under the domain of central armed police forces, plus depending on the needs and requirement and the extent of disaster, Indian military was involved, plus obviously local law enforcement, that means local state police, depending on where disaster has occurred, they were made part of it. So to some extent it was very fragmentary in nature. CAPF, that means CRPF, BSF, whichever CAPF is nearby, they used to be called upon. But as you can see, these people, these organizations do not have the prime responsibility as disaster response. They are doing it as an additional task. Their main duty, why they are raised? They have been raised largely to fight the enemy of the state. So fighting Naxalism, patrolling along the border, ensuring that northeast insurgency is controlled. So if you are putting the same group of people, same forces in the work of disaster management, their core task is compromised. So that also was one of the reasons why it was envisioned that we should have a special disaster response force, both at the national level where you have national disaster response force, and then at the state level where you have the state disaster response force as such. So in beginning, very few battalions were instituted, but now we have expanded it. Total today, NDRF has 16 battalions all across India, and the number of personnel are 18,556. Now you will ask that where these personals are recruited from. So again, these personals are largely coming from the CAPF itself, but there is a difference. Now, those personnel who are made part of NDRF, their only task is to do disaster management, to respond whenever and whatever kind of disaster struck. They are not responsible for any other task as such, to maintain or ensure security of India, or to go and carry out this counter Naxal operations or counter insurgency operation. They do not participate in that. So you have a force that is fully prepared and fully ready to respond whenever disasters strike any part of India as such. So all across the country, 68 locations are there where currently NDRF battalion, NDRF regiment are deployed, because we know that more than 55% of India's area is prone and vulnerable to different kind of disasters. So if you have the wide dispersion of NDRF battalions, depending on whichever battalion is nearest, they can respond quickly. So rescue response time would be has been drastically cut down. Operational zone wise, they have 4 operational zone. However, the headquarters is obviously in New Delhi, and you have 18 search and rescue teams attached with every battalion of NDRF, because you know that whenever any disaster strike, the first responsibility or first focus is to ensure that the human casualty can be reduced. That means lives have to be saved first, infrastructure, economic damages and all that, then that comes to secondary. So search and rescue is the first and most important operation launched in any disaster, and that is why this is also given equal importance in the overall structure of NDRF as such. Then if you look at training infrastructure, they have well dedicated training academy called as NDRF Academy, that was instituted in 2018. So almost 12 years after NDRF was raised here. Apex Training Institute, new campus is being opened in Nagpur also to provide better training and training to more number of people. Mandate, again, both responding in natural as well as man-made disaster. Natural disaster means earthquake, tsunami, cyclones, right, landslides. Man-made disaster means industrial disaster, chemical, biological, radiological, nuclear disaster we can talk about, floods, collapsed structures and all that. CBRN, same thing we have discussed. CBRN is chemical, biological, radiological and nuclear incident. Plus, since 2022, forest fire we just have discussed in first topic. Due to the effect of climate change, global warming, the incident of forest fire is continuously increasing. So, to handle and tackle forest fire, NDRF is also called upon. Plus, we know that India also has sent NDRF battalion to tackle the international disasters whenever the requirement was there. So in case of Japan, again, same thing. Earthquake plus tsunami, we have discussed. Fukushima disasters. That time NDRF battalion was sent. Nepal 2015, one of the most devastating earthquake of recent history. Nepal has witnessed in Kathmandu region, there it was sent. And most recently, Turkey 2023, more than 60,000 people died in Turkey 2023 earthquake because of the we have discussed here along the Turkey, the earthquake was caused by continental transform plate interaction. So go through it, try to read about it. So that caused heavy casualty. There also NDRF battalion was sent. And 2024, NDRF has declared it to be the year of CBRN preparedness. So this is some other fact you have to keep in mind. NDRF is not only responding within India, but also we can say they are called upon to help countries which need their this help as such. So now coming to few questions, if you look prelims based question, with reference to Japan's post-Fukushima nuclear energy policy, consider the following statement. After 2011 Fukushima disaster, Japan shut down all its nuclear reactors for safety review. Second, restart of nuclear reactors is aimed at improving energy security and meeting climate commitments. Third, Japan completely abandoned nuclear power in favor of renewable energy after 2011 as such, right? So what is the correct option? First, this point is correct as such. Second, restart nuclear reactor is aimed at improving energy security. We have discussed Japan is trying to diversify, and also it is we can say the nuclear restart, it is claiming to be as effort taken for decarbonization. So this also is correct as such. This is incorrect. It did not completely abandon nuclear power. It has temporarily, we can say, shut it down. So 1 and 2 we can say will be the correct option here. Then with next to talk about with reference to NDRF, consider the following statement. It was established under DM Act 2005. It is mandated to respond only to natural disasters and not man-made disasters. CBRN, chemical, biological, radiological and nuclear disaster or nuclear response is part of its operational mandate. So obviously first statement is correct. Second statement is not correct. We have just discussed, no matter which kind of disaster, whether it is natural or man-made, in both cases NDRF has mandate to respond to carry out search and rescue operation. So correct answer will be B, 1 and 3 only. Then coming to, with reference to INS Sagardhwani, consider the following statement. It is a marine acoustic research vessel of the Indian Navy. It was designed by the Naval Physical and Oceanographic Laboratory, in short called as NPOL, in Kochi. It plays a role in enhancing India's underwater domain awareness. What is the correct answer? So here we can see all of these are correct. Marine acoustic research, acoustic again because using sound wave, acoustic waves as such. Designed by NPOL, we have discussed too, and it overall plays a very important role in enhancing understanding of underwater domain. So D, that is 1, 2 and 3, all of these are correct option. If you look at the importance of each of the topic that we have discussed, snowless winter, the most important one, 5-star we can say, because it is directly linked to your syllabus. In syllabus we have to study about climate change. In syllabus we have to study about the climate of India. In climate of India, we have discussed already the impact of western disturbances. We have talked about the effect of subtropical westerly jet stream on the southwest monsoon, northeast monsoon. So directly related to climate change, directly related to the geographic concept static plus current affairs based relevance it has. So all of this make it very, very important. So make sure that you go through it, understand the concept, write all the important data and factors. Second is post Fukushima start, not very important, but indirectly you can use it to talk about the nuclear energy. Whenever you talk about the government policy where it is trying to expand, government of India talking about, they're trying to expand nuclear energy or nuclear energy generation. So what kind of what kind of risk India will face, that we can also learn from and also understand by looking at Japan model as such. Plus indirectly linked to volcano zone. Why Japan has to shut down its nuclear power plant? Due to volcanic activity, earthquake activity and the flooding activity, tsunami basically we can say. So you can link with the plate tectonics, directly linked to plate tectonics. Delta submergence again important, because in UPSC notification you will see in geography one topic is mentioned, important changes in the landscapes around the world. So the subsidence of delta, submergence of delta obviously comes under this important change. So here mains based plus pre based, both kind of question you can expect UPSC would ask from here. Go through this. INS Sagardhwani, not very important, just match the following one. Prelims based question can be asked, that what kind of vessel it is, research vessel, military vessel and all that. And NDRF again, directly question will not ask about the NDRF raging day and all that, but you can use the pointers we have discussed whenever you are answering disaster management based questions in GS3 paper, because many times they ask, in case of any disaster, what are the steps taken by government of India to make sure that disaster management is robust in India. So one step you can say is raising of a dedicated force called as NDRF. So very important to keep these pointers in mind. So that's all as far as the topic of this particular week is concerned.